This session is about lessons from meta-research, systematic reviews, and meta-analysis. First, what is meta-research? It's the study of empirical research. Meta-research teaches us how research is actually conducted, which research methods and measures can produce reliable and valid information, how research is reported, how research results are disseminated at conferences and scientific reports and publications, and through citation networks. Meta-research also teaches us about common sources of bias and error in the conduct, reporting, and dissemination of empirical research. So let's look at how research is conducted, how research is reported, and how reviews of research are produced. Now, ideally, studies collect a bunch of data, and here I'm going to describe that on a fairly simplistic horizontal axis from negative results that suggest that our hypotheses are incorrect to positive results that support our research hypotheses. So studies collect a bunch of data, and results are mixed on this simplistic axis. And then researchers produce research reports, and at that point we're already summarizing some of the data collected. So, for example, research reports don't produce raw data, they produce averages and other statistics based on data summarizing what was found. Now here I'm thinking about the full technical reports of a study. And then based on those technical reports, we produce publications in journals, articles, books, and so forth. And publications tend to be a subset of all of the research results. So here we're going to highlight perhaps most important results with some of the technical details left to the full scientific report. And then ideally, research reviews summarize publications and research reports on all of the studies on a particular topic, right? Yeah, we wish. That's not how it works, not at all. In fact, the reality is much more like this, that at every step in this process, there is a bias toward positive, significant results. And we know a lot about this through decades of meta-research that show that in the first step, there is a process called outcome reporting bias, and that's followed by publication bias, and it's compounded by a bias that affects what we now call haphazard reviews of research. Now, this is so important that I want to say a little bit about what we know about each of these steps. So in general, meta-research shows empirical evidence of bias, that selective reporting, publication, citation, and selection of evidence tends to confirm our favorite theories, that it overestimates the benefits and underestimates the harms of favored treatments. And there's 3 decades, 4 decades of research showing this pattern. Here are some of the main citations. So let's look at outcome reporting bias. Outcome reporting bias is what happens when studies collect data and go to report results. So it's defined as the selective reporting of outcomes based on their direction, that is, whether they're positive or negative in relation to a hypothesis, and on their statistical significance. So we'd like to see all outcomes reported regardless of their direction, regardless of whether they support what we thought was true or not, and even if they're not necessarily statistically significant, we'd like to see all of the results. But instead, what happens is some cherry picking, that researchers select data that support their hypotheses. And in psychology, there's a phenomenon that's fairly well established called harking, which is hypothesizing after results are known. And this means that researchers collect data and develop new hypotheses to explain their significant results. So the data are driving hypotheses instead of the other way around. What we see here is the disappearance from research reports of unsupported hypotheses and non-significant results, and this contributes to outcome reporting bias. So there is empirical evidence of outcome reporting bias showing that this distorts published research results, showing that statistically significant and positive results are more likely to be reported in technical reports. That is, they're more likely to be mentioned at all, and they're more likely to be fully reported. That is, data are provided so that readers can see the full results. Now, these reporting biases occur within studies, and they're unrelated to the study or outcome quality. Now, the problem is that if poor quality outcomes were dropped from research reports, that wouldn't be a big problem. That's not the issue. The issue is that researchers are collecting data on a variety of outcomes and reporting the results that support their hypotheses and not reporting equally valid results that do not support a priori hypotheses. So this is a study, a systematic review of the empirical evidence of publication bias and outcome reporting bias, a study published by Duan and colleagues in 2008 that shows that statistically significant outcomes are more likely to be reported than equally valid but not significant outcomes. And here the odds of being reported are between 2 and 5 times greater for statistically significant results than non-significant results. Here's a study of potential outcome reporting bias in neuroimaging studies of sex differences. So this problem of outcome reporting bias has been detected in all disciplines and all fields. The next step is publication bias. So we do know that only half of completed studies are actually published. And here the Jones et al. Study published in 2013 is a study of very large randomized controlled trials in medicine, huge studies involving thousands of people. And they found that only half of those studies were ever published. The other studies exist in government archives or in somebody's file drawer. We also know that publication rates may be even lower than that in the social sciences for observational studies and in low and middle income countries. In fact, the only really rigorous study of publication rates in psychology found that 31% of completed studies were published. And that's this study by Cooper and colleagues from 1997. 31% of completed studies were published. That means a lot of the research that is done does not see the light of day in terms of publication. Publication bias means that studies with significant positive results are 2 to 3 times more likely to be published than similar studies, that is, equally rigorous, equally valid studies with null or negative results. Again, the likelihood of publication is related to the direction, that is positive or negative, and significance of results, quite apart from the influence of anything else. So publication status, whether a study is published or not, is not a good proxy, it's not a good substitute for methodological quality. Whether a study is published or not does not tell us how good it was. We tend to think of the peer review process as an insurance of quality, but that's not the case at all. So publication status should never be used as an inclusion criteria in reviews of research. In other words, we should never leave out of research reviews studies that weren't published, because if we do that, we're likely to bias the results of the review. Publication bias may actually be getting worse over time. This is a study published in 2012 that shows that negative results, results that do not support the researcher's hypotheses, are disappearing at a faster rate over time. We know a lot about the sources of publication bias, about why this happens, and it's clear that the sources of publication bias are quite complex. That investigators, that is the researchers themselves, don't think that null, that means non-significant, or negative results are worthwhile, and or they don't expect these results to be accepted for publication or to be published. So they're less likely to submit null or negative results for conference presentations and publication in journals. Peer reviewers and editors may be less likely to accept or publish null results, but there is some contradictory evidence on that. Mahoney found evidence of journal publication bias in the late 1970s, but more recent studies have shown that that's really minor compared to the problems of publication bias at the investigator or researcher level. So Song and colleagues concluded that publication bias appears to occur very early, mainly before the presentation of findings at conferences or submission of manuscripts to journals. Now, I've done some studies of this myself. In fact, I interviewed an investigator who conducted the largest, most rigorous study ever done on a particular topic that I'll talk about again in a little bit. And this was a very large study. Actually, it was conducted in Ontario, Canada, that found no evidence that supported the main hypothesis. And I asked the researcher, why didn't you publish this? And he said, well, we didn't find anything, meaning that they had no statistically significant results. And I said, well, yeah, you did. You found that there were no statistically significant results. And he said, oh, yeah, okay, but nobody would publish this. So he's not going to submit it for publication. We'll see in a little while that that's a real serious problem. So on top of this, there are several sources of dissemination bias. Studies with statistically significant results are published faster than other studies. They're cited and reprinted more often, so they're easier to locate, especially in English. So we see that reporting, publication, and dissemination biases are ubiquitous. That means they're everywhere. They are cumulative, and they tend to inflate estimates of effects of favorite treatments and support for researchers' hypotheses. So here's the problem in our literature. An example is provided by three publications. The first on the left, titled Why Most Published Research Findings Are False, was published by John Ioannidis in 2005. And he shows that most published research findings are fairly extreme. They tend to support the researcher's hypothesis, but they don't hold up on further examination, and they aren't replicated in subsequent studies. The second article by Young and colleagues shows why current publication practices distort science. And the third article, one of my all-time favorite studies by Greenberg, published in 2009, shows how citation networks create an unfounded sense of authority. Greenberg shows that as researchers cite previous studies, biases creep in to the citation patterns, and researchers tend to cite only the research that supports what they think they already know. So research reviews actually can make this problem worse. Haphazard reviews add to this pattern of biases. And let me explain how this happens. Bias and error can enter into the research review process in several ways at different stages, including when we search for studies, when we select studies to include in a research review, when we extract data from those studies, when we analyze that data, and when we synthesize the results across multiple studies. So here's some examples of that. When we're searching for studies, if we're using bibliographic databases, these sources are largely limited to published studies. So our search results can be affected by publication bias. When we select studies to be included in a review, trivial properties of those studies or reports will affect our recall and evaluation of information. So for example, Bushman and Wells conducted a randomized experiment looking at the impact of the wording of titles of research reports on whether or not readers remembered what the research reported and how they evaluated the quality of that information. So in this study, they randomly assigned people to reading different kinds of research reports, and in some of the reports, they used very snappy, catchy titles. And other copies of exactly the same research did not have these snazzy titles. And what they found was that the people who read the same research report with a snazzy title tended to remember that research better and tended to think the results were more valuable. Now that's a problem because these were very trivial properties of the study. The wording of a title should not affect whether or not you remember the information and whether or not you think the information is valid. But it does. This is an example of selection bias. Next, when we extract data from studies, this is a very difficult process. It's hard to know what some researchers are reporting, and empirical evidence shows that errors in extracting data from studies are very common, that initial agreement about what a research report says is low. When you're comparing observations from two trained observers, experts reading the same report, they tend to disagree on what the report says. So experimental evidence shows that duplicate extraction of information from studies reduces errors. That means to really understand what a study is saying, what we should do is have two or more people independently read the research report, take notes, and then compare notes on what they thought the study said. There are several ways of synthesizing results of research across multiple studies. We know that narrative synthesis, simply writing a text report, is unduly influenced by trivial properties of studies, such as memorable titles, and it's far less accurate than meta-analysis, which is a careful statistical synthesis of results across studies. So our traditional narrative research reviews are likely to be affected by all of the sources of bias and error that I've talked about so far. Another approach is called vote counting. This is not a good alternative. Vote counting means that reviewers count up the number of studies that had positive, negative, or null results. So for example, I might tell you that I found 10 studies. 6 of them had positive results that supported my hypothesis. 2 of them had null results, no significant results. And 2 of them had negative results. But this tells you absolutely nothing about what this body of research says, because it doesn't consider the size of these samples or the variations within them, the heterogeneity within different research studies. So the overall results depend on sample size and precision. In a set of 10 studies, it could be that the 6 studies with positive results are tiny little studies or poorly conducted studies that really don't matter. And the weight of the evidence really is in the 2 null or 2 negative studies. Perhaps those are large, rigorous studies with many thousands of people and ample evidence. Or it could be the other way around. It could be that the 6 positive studies are the big, rigorous ones and the other 4 are not. So simply counting the number of studies with positive, null, and negative results tells you absolutely nothing. But this is a common practice. So here's an example of a review of 38 studies, irrespective of quality, comparing women's psychological well-being and their paid employment status. And what you see in this table is the reviewers are simply counting the number of studies that provide positive or not significant results for different groups of women in different areas of psychological well-being. The numbers in this table are the number of studies with positive or null results. Again, that tells you nothing. Vote counting appears in many forms. Sometimes you see graphs like this showing, again, positive, no change, and negative results. And this is such a terrible practice that it's been argued that this vote counting can actually kill babies. Well, vote counting itself doesn't actually kill babies, but there is a serious argument to be made here. This graphic on the right is the Cochrane logo. It represents a forest plot. I'm going to describe forest plots in much greater detail in a little while, from a systematic review published in the Cochrane Library a long time ago, 1991. This review included 7 randomized controlled trials of the effects of corticosteroids for mothers who were about to give birth prematurely, and they looked at the effects of corticosteroids on infant mortality. So, in this logo, the results of each study are shown as horizontal bars, the purple horizontal lines. The purple vertical line is the line of no difference. So what you see in this graphic are that 5 studies have horizontal bars that cross the line of no difference. That means they found no significant effects, no differences between the group of moms who were given corticosteroids and the group of moms who were not given steroids in birth outcomes. 5 studies show no statistically significant difference. 2 studies, the very top and one of the latest bars, are apart from that vertical line of no difference. This means these 2 studies showed significant reductions in infant mortality associated with corticosteroids. So if I was doing a vote count based on this graphic, I would tell you that 5 studies show there's no difference in giving steroids and 2 studies show there is, so I might conclude that the weight of the evidence is that steroids don't work. That's not right. The diamond at the bottom, near the bottom of this graphic, is the result of a meta-analysis that statistically combines the results of all 7 studies. And it is apart from the vertical line of no difference. It's off to the left, showing that overall, these 7 studies provide strong evidence that the use of corticosteroids reduces infant mortality. We didn't see that in 5 of the studies because they were small studies. But overall, this body of evidence says that corticosteroids reduce neonatal mortality and save lives of newborn children. If you were relying on vote counting, you would increase infant mortality. So, to sum up, bias and error are common at every stage of the research process, in reporting the results of studies, in publication, in dissemination, and in research reviews. So, this is the problem. Now, I talk about this a lot at conferences and in professional and scholarly meetings, and when I get to this point, a lot of people say, really? Is it really that bad? Yes, it is. And let me give you a very concrete example to help you better understand how this works. So let's take a look at one study published a long time ago in 1987, and we'll take a look at how the investigators made use of their data and how reviewers made use of the data. This analysis is published in the journal Children and Youth Services Review in 2008. So the example is one article in which parent training was compared with multisystemic therapy. This article, again, published in 1987 in one of the top journals in psychology, the Journal of Consulting and Clinical Psychology. This article is based on Molly Brunk's dissertation. Her co-author, Scott Hengler, is the developer of multisystemic therapy, which is a home and community-based intervention for youth with problems in juvenile justice, child welfare, or mental health systems. But in this case, the sample involved 43 families of abused or neglected children who were randomly assigned to one of two treatments. Families either received parent training in groups, or they received multisystemic therapy in their home and communities. Of the 43 families, only 33 actually completed the treatment and provided data on outcomes immediately after treatment. There's no follow-up data available in this study. Researchers collected data on 30 outcomes, that is, scales and subscales. So let's take a look at what you would get if you collected data on 30 outcomes purely by chance. So according to probability theory, if we have 30 outcomes and we just roll these dice, purely by chance, we're likely to get one that shows advantages of the parent training group and one that shows advantages of the multisystemic therapy group. But for the most part, we would find no differences between the groups, purely by chance. Now let's take a look at what the researchers actually found. Something a little different than chance. They actually found 2 outcomes that showed the parent training group did better, 5 that showed that the multisystemic therapy group did better, 22 that found no differences between the 2 groups, and 1 outcome measure was not reported. We don't know what happened to it. It just disappeared. Okay, let's take this data and organize it. And now I've organized it on this bottom horizontal axis. 2 points for the red team, 5 points for the green team. Mostly we have no difference, 1 piece of data missing. Okay, what do the researchers do with this information? Well, in a table in the published report, they provide data on all 7 of the statistically significant results, and they provide data on 12 of the 22 non-significant results. And that's outcome reporting bias right there. So they have dropped information on 10 outcomes that were not significant. The next thing they do is they provide a narrative summary, and here I'm looking at the abstract of this report, and I've coded their summary of this results using content analysis, and that's the top bar that you see there. I show 1 point for the red team, 1 point for the green team, and 3 statements showing no difference. Now that content analysis comes from these statements in the abstract. They say, both groups showed decreased psychiatric symptoms, that's 1 point, reduced stress, number 2, and reduced severity of identified problems, number 3. Now they're saying that both groups showed that, so there's no difference between groups, so I'm counting that as 3 null statements. They say that MST was more effective than parent training at restructuring parent-child relations. That's 1 point for the MST green team. And parent training was more effective than MST at reducing identified social problems. 1 point for the red team. Okay? Now, I think that's a fairly balanced abstract. They've cut out a lot of the white space. They've cut out a lot of the results that show no difference between the 2 groups, but they've come up with a succinct summary that gives us a sense of balance. Take a look at what reviewers said about this Brunk study in published reviews. So now I'm using content analysis, the same thing I did with the abstract of the Brunk study, to show you what the reviewers said. So the top line is in a published review by Barbara Burns. In the text, she makes 3 statements that indicate the groups were equal in some outcomes, and 2 statements suggesting the MST group had better outcomes. No mention of points for the red team. And then in a table, she uses a single statement to characterize the results of this study. And that statement is, this study shows that MST reduced parent-child relationship problems. Now, that statement is true. That is one of the advantages of the MST intervention in this study, but it is not a complete report of the results of this study. And then looking at the rest of this graphic on the right, you see that different reviewers come up with different statements about what this study has found. But most reviewers use a single statement to describe the results of the study, and that statement is something like, this study shows that MST is more effective than parent training for families of abused and neglected children. And that is not the whole story. So what we have is a single phrase used to characterize the results of this study, highlighting the advantages of one approach. And this ignores valuable information on the relative advantages, disadvantages, and equivalent results of these two different approaches. So we've lost a lot of really important information here. If my goal is to reduce parent social isolation, it's clear from the results of this study that the parent training groups were more effective at doing that. But you don't get that in the published reviews. If my goal is to reduce parent-child interaction problems, MST does seem to work better in those outcomes. But for the most part, the differences between these two groups are fairly small. So if my client would prefer to be part of a group or not, would prefer to receive intervention in their home and community, client's preferences could drive the selection of intervention if we had all the information, but we don't in most published reviews. So systematic reviews aim to correct this problem. They aim to sum up the best available evidence in a way that minimizes error and bias at each step in the process. To do this, we use explicit, replicable research methods to identify relevant studies, and we use objective techniques to analyze those studies. We develop and follow a predetermined plan called a protocol, and we conduct secondary analysis of existing data. Here we treat the review process as a form of survey research and follow basic steps in the research process. But research reports, rather than people, are being surveyed. Each research report is interviewed by a coder who codes information and quantitative findings. Multiple coders review each report and compare notes. So we're basically studying the studies. Systematic reviews use these steps to reduce bias and error. First, they set explicit inclusion and exclusion criteria indicating what kinds of studies will and will not be included in the review. Then they develop and document strategies for locating all relevant studies, regardless of whether they're published or not. Then they use inter-rater agreement, a form of reliability, to make sure that their key decisions are sound, to make sure that data are extracted from studies in a reliable manner, and to make sure that their coding of information from studies is accurate. They conduct a formal assessment of study qualities, known as a risk of bias assessment, to make sure that they understand the relative strengths and weaknesses of different studies in the review. And then they use meta-analysis, whenever possible, to synthesize results across studies. So meta-analysis is a set of statistical procedures used to assess averages across studies, variations across studies, potential sources of variation, which we call moderators, and risks of bias, that is, tests for publication and small sample biases. Systematic reviews don't always include meta-analysis. They might include a narrative synthesis or no synthesis at all if there aren't enough results to combine. or they can include multiple meta-analyses. And meta-analysis, the statistical part, is not always based on systematic reviews. And this is a problem. So many published meta-analyses use convenient samples of published studies only. So if they're only based on published studies, then they are vulnerable to publication and dissemination biases. So meta-analysis alone is not enough to counteract the kinds of biases that exist in the reporting, publication, and dissemination of research results. For that, you need systematic reviews that explicitly aim to minimize bias. There are international standards for the conduct of systematic reviews that are cross-disciplinary. So the Campbell collaboration has a set of standards we call them Messier standards. They're based on Cochrane standards. PRISMA is another set of standards. The U.S. Institute of Medicine has standards for the conduct and reporting of systematic reviews, as does the American Psychological Association. The good news is that these independent groups agree on many issues, especially on methods to minimize bias and error in research reviews. They all agree that systematic reviews should be conducted, that they should publish a protocol that is detailed plans for a review before beginning the review. They must take reporting and publication biases into account by searching for gray literature to get unpublished studies, and by assessing the risk of publication bias in each review using statistical techniques to do that. They agree that reviewers should document their methods and decisions in sufficient detail so that others can replicate the work, that reviewers should use structured data extraction and coding forms, that they should double code and check the accuracy of their work to reduce errors, and they should use meta-analysis if possible. And it's possible to use meta-analysis if you have 2 or more studies that produce quantitative results. It's important to say that some reviews that are called systematic reviews aren't. They don't meet these basic standards, and that these international standards for systematic reviews and meta-analyses are not followed by many peer-reviewed journals, by U.S. government agencies, including the Substance Abuse and Mental Health Service Administration, by prestigious professional groups, including Blueprints for Violence Prevention, and by many clearinghouses, including the California Child Welfare Evidence Clearinghouse. There are established guidelines for the critical appraisal of systematic reviews and meta-analyses. We're going to use the AmStar guidelines in this class. They're less than ideal than the other guidelines available, but they're easy to use. So there is an AmStar 2, a more recent version of AmStar, but it's more complex and I don't think it's necessarily worth the effort. And there's also another set of guidelines called ROVIS, which has better research properties, but is also more complex, and we will not be using that. So let me give you an example of a systematic review and a meta-analysis of the effects of multisystemic therapy. This is a systematic review and meta-analysis that I conducted with colleagues within both the Cochrane and Campbell collaborations. Cochrane and Campbell are international organizations devoted to the production of high-quality systematic reviews and meta-analysis to inform policy and practice. Cochrane works in healthcare, Campbell works in the fields of social care. Our protocol for the systematic review was published in 2004. A full report on results of the systematic review was published in 2005, simultaneously in the Cochrane Library and in the Campbell database of systematic reviews. In addition, there are 4 published articles about this review in the journal Children and Youth Services Review, including a debate between myself and the developers of multisystemic therapy. As you'll see, the MST developers don't particularly like our results. So here are the formal inclusion criteria that we set up to indicate what kinds of studies would and would not be included in our review. We use the PICOS format. So the population is youth with social, emotional, and/or behavioral problems, not youth with medical conditions. The intervention of interest is licensed MST programs. MST is compared to any comparison condition, usual services, and alternative treatment or no treatment. Turns out that there are no studies that compare MST to no treatment. So in the research on MST, MST is always being compared to another intervention. The outcomes of interest include out-of-home placements of youth, arrests, delinquency for youth in the juvenile justice system, measures of peer relations, behavior problems, substance use, psychiatric symptoms, and family functioning. Studies of interest are randomized controlled trials because this is the design that is best suited to detecting effects of interventions. And it's also the study design used most often in studies of MST. We had no language or geographic restrictions, so we included studies conducted anywhere in the world, reported in any language. So we developed a search strategy to find all of the relevant MST studies. We did this in consultation with information retrieval specialists, librarians. We scanned available reference lists, made personal contacts with program developers, researchers, and other experts to be sure to get all studies, not just published studies. And we conducted keyword searches of electronic databases and websites. A full list of the sources that we used is included in our published protocol and in the systematic review. We used strings that were actually much more complicated than the search string shown here, but they included these key terms for the most part. The search produced more than 5,000 hits or citations. Many of these hits were not actually to citations to research reports. They were discussions, practice papers, and so on. But we did find 266 unique titles and abstracts. They were screened by 2 reviewers independently. And then we, if either of us thought that the title or abstract might be relevant, we pulled the full text. This resulted in acquiring 95 full text reports. Each of these reports was screened by 2 reviewers independently. We then compared notes and decided which of these reports involved an MST outcome study. This led us to identify 35 unique MST outcome studies. Of those, 8 studies met our eligibility criteria. Some of them were ruled out because they dealt with kids with medical problems. Many of them were ruled out because they hadn't been completed yet. So the 8 studies in our review involved 1,151 participants, that is youth and families. In terms of data extraction and coding, we collected information on each of the studies, including their research methods, the interventions involved with the MST and the alternative intervention, and characteristics of the sample. We collected information on reports on each study. We found that many studies had multiple reports. So for each report, we collected information that was bibliographic in nature and collected information on the sample and subsamples reported on. And then for each outcome in each study, and we had multiple outcomes in each report, we collected information on how the outcome was measured, what was the instrumentation, what measurement was used, when the data were collected and by whom, how many cases provided valid data on each measure, and what the results were. So we collected the raw data and data on statistical analyses. We then conducted an assessment of study qualities. And here we identified a number of problems in the original studies. Many of them used unclear or substandard research procedures. So these were all, quote, randomized controlled trials, studies in which a pool of families with youth were randomly assigned either to MST or to some comparison treatment. But some of the studies systematically omitted families and youth who had dropped out or were, quote, unsuccessful. And they ended up comparing, quote, successful MST cases to all of the other cases in a comparison group. And that's not truly an experimental design. So we rank studies by their adherence to the original experimental design. This is called an intent to treat analysis, and by the quality of their follow-up data, whether they use standardized observation periods. And we sorted the results by these quality rankings, which show our confidence in the results of different studies. So the outcomes included 21 conceptually distinct measures in these categories. So we looked at incarceration for juvenile delinquents or restrictive placement, and here we kept separate analyses of hospitalization for youth with psychiatric emergencies versus foster care placement for youth in child welfare versus incarceration or detention for youth in juvenile justice. We also looked at arrest and conviction in the juvenile justice samples, self-reported delinquency, and so forth. The differences between groups, between the MST groups and groups that received other treatments, were assessed using effect size measures. So an effect size is any measure that shows the magnitude or size and direction of a relationship or an effect. So it shows whether the MST group did better or worse or the same as another group, and it does not rely on the sample size or statistical significance. So it's a really good way to look at the size and direction of a difference. There are two effect size measures used in our meta-analysis. You'll talk about these in the RIP2 class, I believe. The first measure is called an odds ratio, and it's used for dichotomous measures, that is, measures of things like out-of-home placement that either happen or don't happen in a case. And the second effect size measure is called a standardized mean difference. It's used for continuous measures, that is, scales. And here you take the mean or the average of the treatment group minus the mean or the average score for the control group, divided by the pooled standard deviation for both groups. So you've got a difference in averages for the two groups divided by or standardized by the standard deviation. Again, not important that you understand the details of these measures right now, but you will, I think, in a few minutes understand how they work. So here's an illustration of how the standardized mean difference works. If the treatment and control results, let's say these are outcomes on some scale, if the results are identical, then the standardized mean difference, the difference between the two groups, is 0. If the treatment group does a little bit better than the control group, then the standardized mean difference is a positive number. Here I'm showing you a small difference of 0.4. If the difference is larger, then you get a larger standardized mean difference. If the difference is negative, then the standardized mean difference is negative. So the results of our meta-analysis, which summarize the results of multiple studies, are shown in forest plots, which I'm going to explain in the following slides. But if you want more help in understanding forest plots, you can take a look at this tutorial on a really terrific website called Students for Best Evidence. There's a tutorial on how to read forest plots. But here's a forest plot from our meta-analysis on MST. This is actually the first one in our published review. Now, this is a result of this, shows the results of studies that looked at incarceration as an outcome measure. Okay, so what you see here are 4 studies, numbered 1, 2, 3, and 4 on the left side. And the author's name and date are also shown and associated with each study. Now, I told you that we rank ordered these in terms of our confidence in the results. So study number 1 is the best quality study in this set of 4 studies. These are the only 4 studies that provided data on incarceration. This is of juvenile delinquents. So taking a look at study 1, if you move over to the right, you see the second column is treatment. So this shows that there were 70 of the MST cases involved incarceration out of a total of 211 MST cases. And then going over to the next column to the right, you see that in the control group, 63 kids were incarcerated out of a total of 198 families in the control group. So that's the raw data right there. And then over on the right, you have the forest plot. So again, the vertical line is a line of no difference between the 2 groups. And at the bottom, you see actually the effect size scale. So for study 1, you see a blue dot. That's actually the difference. In this case, it's an odds ratio between the 2 groups. And it's very close to that line of no difference because there is no real difference between those 2 groups on this measure. The bar that sticks out to the right and the left of that blue dot is the confidence interval for this odds ratio. And it crosses the line of no difference, the vertical line, which means that these groups really are not statistically different in terms of incarceration. Then going further to the right, we're going to ignore the weight column for now and take a look at the final set of numbers, and this is the odds ratio. An odds ratio very close to 1 means that the chance of being incarcerated is almost identical in the 2 groups. An odds ratio of 1 means there's no difference between the groups. And the confidence interval crosses the line of no difference, so we have evidence that these groups are not different. Okay, then you can ignore the black diamonds in the middle of the graph, but going down the graph, you see that for study 2, we have a result that seems to be to the left of the line of no difference, so it favors the MST group, but the confidence interval crosses the line of no difference, showing that the result is not statistically significant. The third study shows a result that suggests that the MST had higher rates of incarceration. Again, it's not statistically significant. And the fourth study shows that the MST group had statistically less incarceration than the control group because it's not crossing the line of no difference. Okay, what meta-analysis does is it combines the results of these 4 studies, and that's the bottom diamond. So overall, that bottom diamond crosses the line of no difference, suggesting that overall, these 4 studies provide no evidence that MST is significantly better or worse at reducing incarceration than the alternative treatments to which it's been compared. All of the graphs, all of the forest plots in our systematic review look something like this. Some studies show positive effects, but overall, when you look across all of the studies in the analysis, MST is not better or worse than any of the treatments to which it's been compared. So here's the very last graph in our systematic review. This is showing results on a scale of family adaptability. And here we have 2 groups of studies. The study 3 is the best study in this set. One study that shows no difference between MST and the control group in family adaptability. And then in the middle, there are 4 studies that have a range of effects, but overall, no evidence that MST is consistently better or worse in terms of effects on family adaptability. The bottom diamond is the result of the meta-analysis, showing the average across these 5 studies shows MST is not different from alternative treatments in effects on family adaptability. So, the results of our systematic review and meta-analysis show that the effects of MST are inconsistent across studies. There are no significant effects in the most rigorous study. There are a few effects in weaker studies, but none of these are significant on average across studies. This suggests that MST is not consistently better or worse than other services. This does not mean that it's ineffective, it just means it's not better or worse. This is the contrary to the conclusion of other reviews. I've now found 100 published reviews that suggest that the effectiveness of MST is well established. Why do our results differ so dramatically from the results of other reviews? Part of it has to do with what I'll call sampling methods. Traditional narrative reviews prefer published reports in peer-reviewed journals, so they're vulnerable to publication, dissemination, and outcome reporting biases. In addition, there's a lack of critical assessment of primary studies in traditional research reviews. Many reviewers have said, well, these are randomized controlled trials, and that's the gold standard for program evaluation research. But just because a study says it's a randomized controlled trial does not mean that it's really producing top quality information. We have problems with differential attrition and allegiance bias that compromise the quality of randomized controlled trials. We also have a pattern of confirmation bias in searching for programs that work. So how do we think about this evidence of effectiveness in context? And remember, I said before that decisions based on evidence really have to take into account a number of different topics. We have to take into account the goals of our program or provider, the values that we're expressing. We have to take into account our clients' needs and preferences, what practitioners know how to do, resources and constraints, as well as information on the efficacy and effectiveness of interventions. So let's take a look at how the results of the MST studies have been used in policy and practice. MST was discontinued in several contexts. In Canada, the site of the largest MST trial to date, where MST had no significant effects on outcomes and increased service cost, MST was dropped. In Hawaii, MST was discontinued because it was deemed culturally inappropriate. But the program was continued in Sweden, despite the fact that Sweden conducted a very large multi-site MST trial of its own, and they also found no effects of MST, no significant effects on any outcome. But they decided to continue this intervention because stakeholders, including clients, caseworkers, and administrators, liked the structure that MST provided. Now, I would call that an evidence-based decision. They found no evidence of effects, but knowing that, chose to keep the intervention for other reasons. MST was also continued in Denmark for lack of better alternatives, and it continues in the USA and Norway, but on the grounds that there is considerable evidence of positive effects of MST. Now, I don't think that's accurate. I don't think that's an accurate evidence-based assessment. So in conclusion, haphazard or non-systematic research reviews may be hazardous to public health and well-being because they tend to overestimate positive effects of favored treatments, underestimate harmful effects of favored treatments, and underreport the value of alternative treatments. Now, I know this is very complex information, and I'm sure you have a lot of questions about it, so I'm looking forward to talking with you about this further. That's all for now.